Algebraic fractions. So the key to algebraic fractions is always factorise first. So that's the first thing you always do in these sorts of questions. Then, and it's hard to come up with words to describe this, so I say only cancel complete, not bits of them. Okay, so got to be a complete thing. So what do I mean? Well, this one here, obviously there's no factorisation to be done, but that's probably the simplest type of algebraic fraction question we see, where cancelling has to be done. The numbers, we've got 16 on 24 and so on. So 16 on 24 is the same as 2/3. The b squared goes into the b cubed, leaves us b on the bottom. A goes into a cubed, c goes into c cubed. There's our answer. Okay. Always factorise first. Okay. Well, we've got a common factor of a on the top. Always look for the common factor. 2a on the bottom, but we can keep going because we've got p squared minus q squared, which is difference of two squares. So this is what I mean by only cancel complete. So the whole parenthesis bit's got to be the same. And I can see p minus q in both top and bottom, so they will cancel. And we get p plus q on 2. Multiplication. Now we're dealing with multiplication of fractions. Now when we multiply fractions, what must we do first? Anyone? Perhaps I didn't mention it. Always factorise first. Okay, so the first thing we're going to do is factorise. Which one do you reckon I did first? Let's have a look. Well, I don't need to do any factorising there, so I just whack the parentheses around them so I know these are grouped together. Did I do the difference of two squares or did I do the trinomial? I reckon I did difference of two squares. Yes, I did. Okay, so 3x plus 1, 3x minus 1. Okay, you got to think about the way people set questions up in tests. And they do things deliberately because they want to see if you're going to cancel or not. And that can give you a clue. And so I'm going to say here, I don't know for sure, but I reckon there's a strong chance that when I factorise this, I'm going to get 3x minus 1 times x plus 1. Because then that will cancel with the other things that haven't got a pair yet, and it'll make the question nice. Now, I could be wrong, of course. It doesn't hurt to check and make sure. But it can save a lot of time in trying to find out how to factorise it. So you think, well, come on, there's probably going to be one. It might not work every time, but it could save you some. So now we can cancel to our heart's content. The x plus 1 goes with the x plus 1, the 3x minus 1 goes with 3x, everything goes. Don't make the mistake of meaning there's nothing. Of course, we're left with 1. So we just have 1 there. Division. Now we've got something different. When you are dividing fractions, what's the first thing you do? Anyone? Division? What would you do? The second fraction. No, you always factorise first. Okay, so you always factorise first. But you're right. I'm also doing the flip at the same time. We turn it into a multiplication question. So we've got 3a, 6a squared. Well, they're not going to do anything. Which one would I have done here first? Probably the common factor one on the first fraction, I reckon. Yeah, there we go. Pull out the b. Factorise the next one. If I'm going to gamble, well, one of the factors I reckon is a minus 2b. It doesn't help me with the other one. Unless I notice, look at that. That's a perfect square. That's a minus 2b all squared. A minus 2b all squared. So a minus 2b cancels with the a minus 2b squared, the a with the a squared, the b with the b. Oh, and the 3 with the 6 as well. We get 1 on 2a, a minus 2b. What about subtraction of fractions? If you want to subtract two fractions, what do you do first? Anyone? Yes, someone's learnt. Okay, the first thing we're going to do is factorise. But that's actually really, really important with this one, because we have to create a common denominator. Before you add or subtract fractions, you have to have a common denominator. So the question is, how do we work out the common denominator? And the way I think of it is, if it's not there, put it down. So I end up with a minus 1, a plus 1. If it's not there, put it down. So what do I mean by that? I read across, I go, a. Oh, it's not there, put it down. So I wrote the a down. A minus 1, oh, it's not there, so I put it down. A, oh, it's already there, don't need it. A plus 1, it's not there, so I'll put it down. There's my denominator, done. So now I've got to work out the top. What does it become? And that's when I just ask myself, what's different? How did I change the denominator? It was a minus 1. It's now this. What's different? Well, the difference thing is I've added in this new factor of a plus 1. So that is what I multiply the top by. And it becomes a plus 1 squared. Okay, minus. What's different? Oh, it was a plus 1, it's now this. A minus 1, that's what's different. Well, that's what I'll multiply the top by. So I end up with minus a minus 1 squared. Now I just got to work out the top of the fraction. See what happens there. Now, if you recognise patterns, it can be quick. Otherwise, you just expand the whole thing out. So if I did expand the whole thing out, there we go. We've got some like terms there. We end up with 4a. But let me show you something. If you recognise the pattern. Perfect squares. We know always go a squared plus or minus, depending on what it is, 2ab, b squared. Both of them will have the a squared and the b squared. Well, if I'm subtracting, the a squared and the b squared, gone. So what would I be left with? Well, the 2ab, or b in this case is 1 of course, 2ab minus 2ab, 4ab, which in this case is 4a. I can go there straight away. That's fine if you spot the pattern and use it, but remember what I also said at the start of the day? If you find yourself making mistakes, trying those little tricks, then you put the extra steps in. Don't make silly mistakes, if that's what you find it. So what do we end up? Oh, the a's are going to cancel. So 4 on a minus 1, a plus 1. All right, let's try this one then. Woo! It's been factorised for me already. Oh no, not completely. I've got x squared minus y squared there, so let's do that. That's factorised. Got to create a denominator. If it's not there, put it down. So here's my thinking here. X plus y squared, not there, put it down, x plus y squared. X minus y squared, not there, put it down, x minus y squared. X plus y, well x plus y is in the x plus y squared. So whenever you have a situation like that, it's always the higher power that you want. So whatever the highest power is, that's what goes in the denominator. Okay, what's different? Was an x plus y squared, it's now this. So I'm multiplying by x minus 1 squared. That becomes x minus y squared. It was x minus y squared, it's now this. What's different? X plus y squared. So that's what I'm multiplying by. Minus 2 lots of. It was this, it's now this. What's different? Well, I've now squared it. So I've got to multiply the top one by x plus y, x minus y. Some tidying up to do. Here's the quick way, if you spot it. Perfect square plus a perfect square in this case. So that means the middle terms are going to cancel, because one's going to be the minus 2ab, the other's going to be the plus 2ab. Which means I've got 2x squared and 2y squared. But over here I've got the difference of two squares, which is going to be x squared minus y squared, but it's minus that, so it's minus x squared plus y squared, but it's 2 lots of them, so 2x squared. Oh, what should we end up with? Hang on, let me do it again. X squared, that cancelled. So I've got 2x squared plus 2y squared minus 2x squared minus. I should end up with, I think, 4y squared, I think. So let's expand it out if you don't see it. Yes. 4y squared is what we've ended up with. Okay. Use patterns to your advantage if you spot it. Okay. There's our 1D.